8 banned American cars automakers don't want you to remember. Americans love fast cars, loud engines, and bold design, but sometimes automakers go too far, creating cars so dangerous, so unstable, or so shamefully incompetent that they're quietly removed from the road, consigned to oblivion, or buried in corporate shame. Before you watch, support the channel by subscribing and liking. Don't forget to share the video with your friends and hit the bell to stay up to date with future episodes. These aren't just bad cars, these are banned or obliterated American cars that automakers hope you'll never remember again. Number 8. The 1958 Chrysler 300D, the fuel-injected disaster that nearly burned the industry. Today's topic is one of the most ambitious mechanical experiments in American automotive history, and one of the most disastrous, the 1958 Chrysler 300D, equipped with the Bendix electrojector fuel injection system. On paper, this was supposed to be the car that launched America into the future. Instead, it became a cautionary tale of what happens when technology leaps far ahead of reliability. Chrysler introduced the electrojector system with bold promises of lightning-fast throttle response, better fuel economy, and flawless high-performance operation. The reality? Stalling, misfires, hard starts, flooding, engine fires. The system failed so spectacularly that Chrysler pulled it from showrooms within days, retrofitted most cars with carburetors, and pretended it had never happened. Let's dive into why the 1958 Chrysler 300D became one of the most infamous engineering disasters of the 1950s. 1. The letter cars, Chrysler's powerhouse line before the fall. Before disaster struck, the Chrysler 300 letter cars were considered the height of American performance luxury. Enormous Hemi engines, smooth, high-speed highway capability, the prestige of limited production. When the 300D came around in 1958, Chrysler wanted to maintain dominance in the horsepower race, so they decided to leap into the future with something unprecedented: electronic fuel injection. The Bendix electrojector was revolutionary on paper. Sensors fed data to a primitive analog brain box. Injectors fired electronically. Fuel distribution was supposed to be perfect. Instant cold starts promised. Power increases advertised everywhere. Bendix engineers boasted that this system would eliminate carburetors forever. But the problem was simple. The technology didn't belong in 1958. Electronics of the era couldn't handle heat, moisture, vibration, voltage fluctuations, cold temperatures, all of which happen every day inside a car engine compartment. Owners quickly learned that their futuristic Chrysler behaved like it resented being alive. 1. Hard cold starts. The electrojector couldn't function below certain temperatures. In cold weather, the car either cranked endlessly or didn't start at all. 2. Constant stalling. The system would simply cut out at idle, at speed, or in traffic. Owners described cars dying in intersections with no warning. 3. Misfires and surging. Cylinder-to-cylinder fuel distribution was wildly inconsistent. The result, violent misfires, rough running, and unpredictable surges under acceleration. 4. Engine flooding. The injectors stuck open regularly, dumping raw fuel into the cylinders. 5. Electrical failures. Wiring, resistors, connectors, and sensors burnt out, shorted, or simply quit. 6. Fires. Leaking injectors and poor wiring placement meant several early test cars literally caught fire. Chrysler quickly realized the electrojector was catastrophic. Dealers refused to work on it. Cars returned under warranty overwhelmed service departments. Customers were furious. Chrysler's prestige was crumbling. Within days of showing the car, Chrysler issued a silent recall. All electrojector-equipped 300Ds were brought back. The fuel injection units were removed. Standard dual 4-barrel carburetors replaced them. Chrysler pretended the fuel-injected model never existed. Only a tiny handful of original electrojector cars survived, and even those rarely ran properly. The 300D became a ghost model, almost erased from Chrysler's official narrative. Ultimately, the system failed because 1950s electronics couldn't handle engine compartments. Temperature compensation was unreliable. Analog circuits drifted constantly. Injectors leaked. No stable fuel pressure control existed. Onboard diagnostics were non-existent. Heat soak destroyed components. In short, it was genius engineering trapped in the wrong decade. Ironically, decades later, Bosch bought the rights to the Bendix design and used it to develop the earliest reliable EFI systems of the 1970s and 1980s. Bendix was right, just too early. VIX. Legacy, the car that tried to invent the future and failed. The 1958 Chrysler 300D with electrojector remains one of the rarest American performance cars ever built, the most unreliable fuel-injected production car in U.S. history, the first major automotive technology recall of the post-war era, a technical failure so embarrassing Chrysler buried it. Number 7. The 1963 Pontiac Tempest rope drive, GM's most dangerous science experiment. Ladies and gentlemen, today we examine one of Detroit's strangest, boldest, and most disastrous engineering stunts, the 1963 Pontiac Tempest and its infamous rope drive. This car wasn't just unusual, it was a mechanical dare that Pontiac's engineers surely regretted. Number 1. The big idea. A drive shaft that wasn't a drive shaft. Most cars use a rigid steel drive shaft. Solid, predictable, safe. Pontiac said, let's replace it with a 5/8-inch flexible steel cable. Yes, a literal metal rope. It ran nearly 6 feet long, spinning at engine speed, and bent in a permanent 3-inch arc to lower the cabin floor. It looked like a parking brake cable, not a drivetrain component. Why did they do it? Pontiac wanted a smoother ride, lower interior floor, better weight distribution, independent rear suspension. All noble goals, but they gambled with physics, and physics won. Number 2. How the rope drive turned into a highway weapon. That flexible cable worked until it didn't. Catastrophic failure mode number 1. Twisting like licorice. At highway speed, the rope shaft experienced torsional wind-up, harmonic vibrations, oscillation-induced fatigue. Once the oscillation hit the wrong frequency, the drive shaft twisted itself into a knot, snapped, or flailed the torque tube from the inside. Drivers described the moment it failed as being rear-ended by a train. A boom like the differential exploded. The car jumped sideways. And in many cases, it did jump sideways, violently. Number 3. Failure mode number 2. Torque tube detonation. When the rope drive snapped, it shredded itself inside the torque tube, the tube bent or split, The rear suspension violently shifted, and the car lost power, stability, and sometimes control entirely. At 50 to 70 miles an hour, that meant spins, sideways skids, drifting across center lines, overrolls. Pontiac never released exact numbers, but warranty claims were enormous. Number 4. The transmission from another dimension. The rear transaxle was born from a collaboration with the Corvair. That's already a bad sign. The aluminum case transaxle overheated, leaked, whined, lost gear oil, occasionally locked up while driving, and when it locked up, the rope drive took the impact. Sometimes it snapped, sometimes the rear wheels simply froze. Either way, the Tempest became a missile. Number 5. Discontinued quietly. GM's code for "we screwed up." Pontiac did not issue a recall, they did not warn customers, they did not admit fault. They simply let the 1963 model year end and pretended the rope drive never existed. In 1964, the Tempest returned with a normal drive shaft, a normal transmission, a normal suspension, and the rope drive became GM's forgotten mechanical embarrassment. Number 6. Why the rope drive failed. Engineering missteps. Underestimating torsional vibration, overestimating cable fatigue strength, poor thermal management, unpredictable harmonics, a torque tube too weak for the loads. Real-world problems. Cable stretch, misalignment, rear transaxle failures that cascaded into drive shaft failures. Catastrophic failure behavior at highway speeds. The system could work in a laboratory. It could sometimes work in city traffic. But on real American highways, it was a disaster waiting to happen. To be fair, the rope drive Tempest was innovative. 50-50 weight distribution, low floor height, IRS in an era of solid axles. But innovation without reliability is just engineering fiction. The Tempest rope drive remains one of GM's boldest experiments, one of its most dangerous, and one of the most quietly buried failures in Pontiac's history. Conclusion. The 1963 Pontiac Tempest rope drive stands as a reminder of how far automakers once pushed the envelope and how badly things could go wrong when theory met the rough pavement of the real world. It was daring, it was clever, it was beautiful. Number 6. 1969 AMC Hurst SC/Rambler drag package. The factory hot rod too dangerous for the streets. Today's lecture dives into one of the most unhinged performance cars ever pushed onto American roads by a major automaker. A car that looked like a patriotic cartoon and behaved like a street-legal hand grenade. The 1969 AMC Hurst SC/Rambler wasn't just fast. It wasn't just loud. It was a factory-built drag racer shoved onto public roads with so little civility that several U.S. states refused to register it. Let's analyze why. 1. AMC's crazy idea: build a drag car for the everyday driver. In 1969, AMC was desperate. Big three muscle cars were devouring the market, and AMC needed a headline: fast. So they teamed up with Hurst Performance, the kings of shifters and quarter-mile theatrics. The mission was insane. Build a mid-size grocery getter that can run low 14s in the quarter mile, right off the showroom floor. The result was a compact sedan with a massive 390 cubic inch V8, 315 horsepower, underrated, a Hurst 4-speed, 3.54 or 4.10 rear gears, Ram air hood scoop, straight-through exhaust loud enough to wake a cemetery, and paint so loud you could spot it from orbit. 2. The factory drag package, a time bomb with plates. AMC offered a stripped extreme version meant for drag racers who wanted to skip the aftermarket. This was the drag package, and it was trouble. It featured minimal sound dampening, no performance-limiting emissions or muffling, ultra-rich carb tuning for maximum quarter-mile blast, suspension stiff enough to break your spine, traction so uneven that hard launches snapped axles, a curb weight under 3,100 pounds with 315 HP, dangerous power to weight in 1969. It wasn't made for roads, it was made for launch pads. 3. Why states refused to register it. Several states, especially those with strict noise, emissions, and safety rules, turned the SC/Rambler drag package away at DMV counters. The main problems are A. Noise violations. The SC/Rambler exhaust barely qualified as a muffling device. Idle sounded like gunfire. Full throttle was airport runway during jet takeoff loud. B. Emissions non-compliance. Drag tuning ran extremely rich. The car belched raw fuel at idle and stung the eyes of anyone behind it. C. Safety concerns. States flagged lack of rollover protection, the violent wheel hop common during acceleration, rear axle failures, poor high-speed stability due to short wheelbase, brakes not matched to engine output. One state inspection officer reportedly described it as a race car with seat belts and registration bolts. Number 5. 1964 Mercury Marauder Fastback Police Package, the patrol car that terrified its own drivers. Today, we examine a strange, rarely discussed chapter in American automotive history. A police-issue cruiser so unstable, so unpredictable, and so deadly at speed that multiple law enforcement agencies banned it outright. The 1964 Mercury Marauder Fastback Police Package was supposed to be a high-speed interceptor. Instead, it became a machine that officers refused to chase suspects with, a car so hazardous that Ford quietly erased it from official fleet offerings. Let's break down exactly what went wrong. The idea: a high-speed interceptor for highway patrol. By the early 1960s, police chases were getting faster. Criminals had quicker cars, and departments wanted big-engine interceptors with better aerodynamics. Mercury pitched the Marauder Fastback as the answer. On paper, it sounded perfect. 390 cubic inch or 427 cubic inch police interceptor V8, 330 to 425 horsepower depending on tune, heavy-duty cooling, police suspension, larger drum brakes, a slippery, fastback design for highway speed stability. It was a fantasy of speed and control. Reality was the complete opposite. The fatal flaw: aerodynamics gone horribly wrong. The fastback roofline was lifted directly from Mercury's NASCAR experiments. But that shape only worked on NASCAR suspensions, NASCAR tires, NASCAR tracks, NASCAR drivers, NASCAR speeds with closed-course safety. On public roads, especially with police gear added, the Marauder's aerodynamics were a death sentence. The problems were severe. A. Lift at high speed. At 90+ miles per hour, the rear end got light. At 110 miles per hour, the car began to float. At 120 miles per hour, it became nearly uncontrollable. Officers described it as the rear wheels were touching the ground, but the car wasn't connected to the road. B. Sudden oversteer. When the rear lifted even slightly, the car snapped sideways violently. This resulted in spinouts during pursuits, multi-car collisions, fatal rollovers. Suspension and weight, a bad match for police use. Adding police gear, radios, shotgun rack, lights, siren, trunk equipment shifted weight distribution further forward. This worsened the Marauder's natural instability. The result was nose-heavy handling, rear-end skittishness, brake fade under repeated pursuit stops, dramatic body roll on hard corners. Officers reported the car leaning so much that the driver could see the road through the passenger window. Number 4. 1952 Packard 300 Ultramatic, the transmission that destroyed Packard's reputation. Today's topic is a cautionary tale from the early 1950s, a moment when Packard, once America's finest luxury brand, gambled everything on an automatic transmission that was supposed to modernize the company. Instead, the Ultramatic became a mechanical time bomb. By 1952, the Packard 300, equipped with this unit, wasn't known for its refinement, luxury, or prestige. It became infamous for one thing: the automatic transmission that overheated until it detonated. This wasn't rare, it wasn't a fluke, it was routine. Let's break down why. Packard's desperation for modernity. By the early 50s, Packard was losing relevance. Cadillac had the powerful V8, Lincoln had the prestige, Chrysler had engineering brilliance. Packard needed something big, something to make headlines. They bet on the Ultramatic, the first fully automatic transmission designed entirely in-house by a luxury automaker. It was ambitious, but ambition without testing is suicide. The Ultramatic's fatal design problem: heat, heat, and more heat. The 1952 Ultramatic had a weak torque converter, poor fluid circulation, an undersized oil cooler, an early lockup clutch that engaged at the wrong times. These combined into an engineering disaster. What happened during real-world driving? Stop-and-go traffic caused the fluid to boil. Uphill climbs overheated the torque converter. Taxi-duty idling reduced pressure until parts scorched. Heavy loads like luggage or passengers pushed temperatures into the danger zone. And once the temperature crossed a threshold, the Ultramatic didn't just slip, it exploded. Clutches disintegrated. Fluid erupted from the vent. Cases cracked from internal pressure. Taxis left trails of smoking transmission oil down entire blocks. Mechanics learned to keep fire extinguishers nearby. Fleet service, the breaking point. The 1952 Packard 300 should have been a perfect fleet car. Big, strong, smooth, comfortable. Instead, fleet managers quickly realized the monster they had purchased. Taxi companies reported Ultramatics failing before 20,000 miles, overheating on hot days even without passengers, repair costs that exceeded the car's value, burned-out clutches every few weeks. Some taxis had 3 Ultramatic replacements in the first year. Municipal fleets, police cars, administrative cars, motor pools had enough. They issued internal bulletins. No further Packard Ultramatic-equipped vehicles will be accepted for service. This was catastrophic. Fleet contracts were one of Packard's last reliable revenue streams. Number 3. 1968 Plymouth Barracuda 440 test mule, when Chrysler stuffed a bomb under the hood. Today's lecture covers one of the most reckless engineering experiments of the late 1960s, the 440-powered Barracuda test mule, a car that should have been a muscle car hero, but instead became a corporate embarrassment that Chrysler rushed to kill. It was not a production car, it was never supposed to be seen by the public, and once journalists drove it, the project died instantly. Why? Because the car was practically undrivable. Let's break down the disaster. The idea: let's drop a big block into a pony car. By 1968, Chrysler wanted a response to GM's big block Novas and Ford's hotter Mustangs. So engineers at Highland Park came up with a bold idea: Put the 440 cubic inch RB big block into the small A-body Barracuda. On paper, it sounded like muscle car perfection. In reality, it was a mechanical death trap. The first problem, the engine didn't fit. The 440 wasn't just big, it was massive, tall, and ridiculously wide. When they lowered it into the A-body engine bay, the engine hit the shock towers. The exhaust manifolds touched the inner fenders. There was no room for cooling. The weight crushed the front suspension geometry. Technicians had to hammer the engine bay, reroute wiring by hand, bend steering components to clear the block. Everything about this engine installation was improvised. Nothing followed engineering standards. The Barracuda became front-heavy to a dangerous degree. The steering practically non-existent. With the 440 wedged in place, the steering linkage had to snake around the block at extreme angles. When turning the wheel, it bound. It stuck. It fought back. It lost assist pressure. It jammed under load. Journalists described the steering as turning a cement mixer with frozen bearings, or unpredictable, or not safe above 40 miles per hour. Once the engine heated up, tolerances changed, and the steering lost free movement entirely. Imagine test driving a car where the wheel simply refuses to turn in mid-corner. Number 2. 1975 Chevrolet Vega V8 Mule. The engineering failure GM tried to hide twice. Today's lecture covers one of General Motors' most infamous "What were they thinking" experiments, the 1975 Chevrolet Vega V8 Mule, a prototype that never reached showrooms because the car literally couldn't survive its own engine. If the stock Vega was already a rolling disaster, the V8 Mule turned it into a mechanical meltdown with wheels. Let's break it down. The motivation: trying to save the Vega's reputation. By 1975, the Vega wasn't just a bad car. It was an automotive punchline. GM was desperate. The idea was simple. Drop a small block Chevy V8 into the Vega. Sell it as a low-cost American performance hatchback. It sounded like marketing gold. It turned out to be engineering hell. The fundamental problem: the Vega couldn't handle heat. The Vega already suffered from a notoriously weak cooling system, thin-wall aluminum cylinders that warped, chronic overheating, failing radiators, bad airflow. So adding a V8, even a mild 262 or 305, meant multiplying the heat output by 2 or 3. The Mule's cooling system was a Frankenstein of improvised hoses, remote reservoirs, and oversized fans. None of it worked. What went wrong? A car that cooked itself alive. Under even light driving, coolant temps skyrocketed. The radiator boiled over. The firewall became scorching hot. Heat soaked into the cabin. The carburetor vapor-locked constantly. After 20 minutes of testing, GM engineers noticed something horrifying. The hood was warping from sheer engine heat. The sheet metal literally bent upward like a baking cookie. Paint bubbled. Underhood wires melted. The firewall insulation smoldered. By the end of the test cycle, the Mule looked like it had survived a house fire. Number 1. 1962 Ford Galaxie 500 lightweight prototype. The car so light, it bent itself out of existence. This car wasn't merely flawed. It was a demonstration of what happens when engineers chase weight savings so aggressively that physics steps in and says, no. The racing madness of early 60s Detroit. The early 1960s were an arms race, not for weapons, but for quarter-mile supremacy. Detroit automakers were obsessed with shaving off tenths of a second. Aluminum, fiberglass, ultra-thin steel, nothing was off the table. Chevrolet had the lightweight Impalas. Pontiac had the Swiss cheese Catalinas. Chrysler was building monster Max wedges. Ford wanted in, and they wanted in fast. The result was the Galaxie lightweight prototype, a test bed designed to determine just how thin a full-size car could be before it became unsafe. Unfortunately, they found that limit almost immediately. What Ford removed to make it light? To create the lightweight Galaxie, Ford engineers replaced body panels with ultra-thin gauge steel, cut structural bracing in the frame, used aluminum bumpers, fenders, and inner panels, installed lightweight seats and minimal interior reinforcement, even drilled holes in non-essential brackets to save ounces. On paper, these changes created a drag strip missile. In reality, they created something closer to a 3,800-pound soda can. The moment everything went wrong. During early drag tests at Ford's proving grounds, something alarming happened. When the Galaxie launched off the line, especially with a high-torque 406 or 427 test engine, the frame did not flex slightly as expected. It twisted. Then it twisted more. On one especially hard run, witnesses said the chassis visibly corkscrewed, and the car drifted sideways despite a straight launch. After only a few passes, the doors no longer lined up, the trunk jammed shut, the windshield cracked under body stress, the steering column misaligned. The frame rails distorted so badly that inspection crews called the car structurally compromised. This wasn't just flexing, it was the chassis giving up its will to live.